All right. I'm not gonna stream for long today, and I haven't been streaming because the first week of next year, I'm gonna do a dopamine detox week, which is pretty much uh, I think it's a new thing, but it's pretty much a week that I'm not gonna have anything that spikes dopamine, like sugar or energy drinks and that sort of stuff. And no entertainment or music or anything like that. So I imagine I'm gonna be pretty bored during that week, and then I'm not gonna allow myself to watch any entertainment or do anything like that. Just work on string and then watch videos about the stuff that I'm working on. And maybe this is C++ videos, maybe other Python videos. But I'm just gonna do that pretty much for the whole week to start off the next year with good momentum. And that's why this final week I'm uh, just going really insane with the food and energy drinks and that sort of stuff. So yeah, I'm probably not gonna be streaming for a long time today. We'll see. Maybe I'll stream for more than 2 hours here. So I played around a little bit with this stuff that I had before. Didn't do much, but yeah, I'm not sure if I'm gonna be able to get what I want out of this, at least through this way with this set trace. And if I can't do it this way, I think it might not be worth it. It's just too much time to build this. So I'll probably go directly and study the library with the graphs that I have already. The sklearn and TensorFlow library. I'm not getting um, I'm getting a couple of functions here using this spec.getSource. This gets the code object of the frame from trace, set trace, and I learned a lot as well. But I don't think I understand exactly how the set trace works, where it starts tracing, because the functions that I'm getting here with the inspect seem to be from other modules, and the functions from the file never show up. The file that I'm trying to study with, which is this file with some AI stuff. So I'm not sure what's going on there. I mean, I couldn't find much documentation about it other than people saying the obvious stuff. Not obvious stuff, but the stuff that I could find on my own, just looking at the file. I think I don't need this line. This pretty much gives the line number of the frame that is being executed. Maybe I can get the file name as well. Well, file name here. Code name. Code dot file name. Let me see on the documentation how to get it. Name a file in which code object was created. File name. I can print here. I think I can erase this. outer here, which was the outer frame from which this frame that I'm tracing comes from. I shows up weak ref something, multiprocessing something, then something with logs. But I never see sklearn here or anything similar to that. I do know, however, that all these libraries are connected. The multiprocessing, the logging, the weak ref stuff. So it might be calling the script but just showing other stuff that I don't necessarily want. And then it stops working once it gets to the non-type, this non-type point. This is getting the source of the code block that is being called. So I think what I'm gonna try to do is study the Viz network graph and try to create a graphical representation of these things somehow. So at least I have a better picture of what's going on. I also researched here. Then people talked about the trace module, but that's only on the command line that you can use. The old versions of Python. So I don't think it's gonna be that useful for me. So one thing I can do, since I have the file names, both from global, I have globals. Let me see what that does again. Global namespace by this frame. Yeah, this is the global file name path. File name global, file name local. Global namespace by this frame. Built-in namespace by this frame. I think what I can do is track the names of the files and create a graph to connect them. Local namespace, F locals. Oh, I already have here. So local dot get. I'm not sure if this is gonna give me a file name for the local namespace, because this code was Vivax that did it, not me. So I'm not really sure what it does. I assume it gets the name because that's what it's printing here. The name of the file. So I have locals, then I can get built-ins. It's gonna be Yeah, now I have the names for all the files. Name for the code, name for the local namespace, the global, and the built-in namespace. So it's showing none of both of those. Hmm. Let me see if I just... So code name shows something, the local doesn't show anything. So maybe if I just put local here, and it's already gonna give me the thing that I want. Without this get. Let's see now. Yeah, but now it's showing me a bunch of stuff. Yeah, the built-ins just gives me an object with all the built-in functions. So that might be unnecessary for the graph. Yeah, this looks way cleaner. The built-ins essentially I just need it just once, probably, because it's probably gonna be all the same built-in modules that are used throughout the script. But so threading, and then this shows main thread, which is local. Local namespace seen by this array. Maybe if I do a get source here, it's gonna be easier to see. Spec get source. So it's a dictionary, but the hmm. Maybe I can search for how to find the location of a namespace. But here it's kind of doing that already. Hey, Flame, what's up, man? I guess the local doesn't have any files. Maybe I would just leave it at the way that was before and not use it. I'll use it later. So only use the code name and the file name global. I'm trying to create a tool to visualize the execution of a script. I know, kind of like you can do with a debugger, where you can step in and step out and step over. But instead of doing that with the debugger, I want to visualize it. But so far, I'm not being very successful because I don't understand what the sysset trace does exactly. And it's kind of hard to find documentation about this. I mean, I found documentation about it, but it doesn't explain really well how it works. So it might be a lot more complicated than I think, than I thought it would be when I started. Because essentially, I just want to see the connection of the lines on the script, so I can study the libraries and everything that is being activated when the script runs. And the debugger is not really good for that. But I mean, I don't have a lot of experience with it. Maybe if I become better with the debugger, then I'm gonna understand it. But from the little I used, I didn't feel like it was really good to understand what's going on. This might be interesting. Information about arguments passed into a particular frame is returned args is a list of the argument names. Maybe if I print, I'm gonna print this and see. Uh, see what way I get. Hmm. No. I'm gonna let it just run while I get some energy drink. Right back. Maybe I will comment out all the other ones. So it's easier to see. Easier to see. Maybe you can do a spec inception there and inspect the arguments of the arg info stuff. If I could understand how the trace works, would be much better though. I think that's the main issue that I'm having here. So these are the arguments that the frame is seeing. Hmm. Get frame info. Get information about a frame. The traceback object. A name tuple. So how is this different from the other one? Maybe this is the one that I'm... No, get arguments. Let me try this one. I should comment out the other one. And this one is gonna be better to understand what's going on. So it gives me the file name, the line number. Yeah, this is actually all the information of the other ones in just one line. Way better. So I think I'm gonna erase all these other ones. This is pretty much all of the other ones in just one tuple. I think I can erase this stuff as well. So let me see here. Yeah, it looks like it activates this threading module, the weak ref set, multiprocessing, and then logging. Maybe I can research these modules and try to understand what they do better.
Hello and welcome to a new series of tutorials where I will be showing you how to create network diagrams.
So, threading module. Understanding threading module. Probably gonna read some documentation. It's gonna be better than videos. Videos probably don't have very in-depth information. Are there any alternatives to make a multiplayer game without sockets? I'm not sure, man. I'm not an expert programmer, just a beginner. But probably. Yeah. Stuff. What language you're talking about? You're going to make the game, and what game is it? And is it for school or for work, or just because you're curious about it? College. Hmm. Isn't now everyone's on vacation? It's kind of weird. It's, wouldn't think that people have assignments until now. It's almost the end of the year. Yeah, but college sucks as well. Fuck college. This article assumes you've got Python basics down pat and that you're using at least version 3.6. To run the example, what is a thread? A thread is a separate flow of execution. This means that your program will have two things happening at once. For most Python 3 implementations, the different threads do not actually execute at the same time, they merely appear to. It's tempting to think of threading as having two or more different processors running on your program, each one doing an independent task at the same time. That's almost right. The threads may be running on different processes, but they will only be running one at a time. Getting multiple tasks running simultaneously requires a non-standard implementation of Python. Writing some of your code in different language or using multiprocessing, which comes with some extra overhead. Because of the way Python implementation of Python works, threading may not speed up all tasks. This is due to interactions with the GIL, that is, I'm not sure how to say this, essentially limit one Python thread to run at a time. So it's pretty much the way that Python runs things, the CPU runs things. But it's a module for that, I guess. So I think from this, probably what syssettrace is doing is keeping track of the execution, but not of the script. So it shows me what's being activated when the script runs, but not what's turning on that activation, if that makes sense. I think that's what's going on here. And that's why these are the parts that are showing. At least that's what I imagine right now. Probably when the functions run, you're gonna have this threading module and this recref set being activated by the functions, which are the modules that are actually running the functions on CPython. But they don't show the connection of the function that is activating them. But here it says set trace shutdown, stop them. Init enter exit. Yeah, maybe these are the functions that are being activated, but how do I see which lines are activating these functions? Line 67, and these line numbers are just for the files and not for the main script. We need to understand what is a trace. Python Global Interpreter Lock. Python Global Interpreter Lock, or GIL, in simple words, is a mutex or lock that allows only one thread to hold the control of the Python interpreter. This means that only one thread can be in state of execution at any point in time. The impact of the GIL isn't visible to developers who execute single-threaded programs, but it can be a performance bottleneck in CPU-bound and multi-threaded code. Since the GIL allows only one thread to execute at a time, even in a multi-threaded architecture or the one CPU core. What problem did the GIL solve? Blah blah blah. Why is the GIL chosen as the solution? The impact of multi-threaded Python programs. Why hasn't the GIL been removed yet? How systrace? How does tracing work? What? There are two ways to inject code to watch a program run: tracing and profiling. They're similar, but intended for different purposes and so have different constraints. The easiest but least efficient way to monitor a program is through a trace hook, which can be used for writing a debugger, code coverage monitoring, or many other purposes. The trace hook is modified by passing a callback function to sys.setTrace. The callback will receive three arguments: frame, the stack frame from the code being run; event, a string naming the type of notification. So the callback will receive three arguments: frame, stack frame, event, a string naming the type of notification, and arg, an event specific value. There are 7 event types for different levels of information that occur as a program is being executed. Call before a function is executed, before a line is executed. Oh, this is another thing here that I forgot. This is only showing if event equals to call. So maybe, which is only gonna show me functions. Maybe I should put this outside of this block and see what it does. And I should comment the other blocks out. Yeah, now it's showing me different stuff. Slightly different things. I don't remember seeing this concurrent. Yeah, but much of the same stuff. Still multiprocessing, logging, and threading. So it has to be showing me stuff from the AI tester because this code doesn't have a lot of lines. I think I can erase this lines as well. Doesn't make any difference probably. So let me keep reading this. Tracing function calls. The call events the generator before every function call. The frame path to the callback can be used to find out which function is being called and from where. So here, see if it's different than call, then it's returning. Call frame.fcode, function name call name. Function name write, ignore write calls from print statements. So he's getting the line number, the outer frame, file name, culture online, online. But this also is doing it differently. The example ignores calls to write as used by print to write just is standard. Oh, so he's calling the function here. That's probably what I should be doing. Call to function name on function line number, function file name, color dynamic color. So he's getting information about the color and the actual frame, and then creating a print statement that says what frame it is, what function it is, what line, what is the file name, and from where it comes from. Tracing inside functions. So I should take this off this and call it here, probably. That's what he's doing. So threading, I think I'm gonna take a picture of this and run it again and see how different it's gonna be. Then I can probably copy the code the guy did there. Yeah, now we're talking. So that's really, really strange. Why the other code was giving me stuff. And this seems like it's never gonna stop. Absolutely insane. So now I think I have something. Yeah, this looks interesting. Yeah, now I'm seeing XGBoost, NumPy, Pandas. The only issue I see with this is that it's probably gonna give me a super complex graph. if I manage to get information. So I think I'm gonna erase the stuff I had here, and I'm gonna copy the stuff from the other guy. Just see what it does. So obviously this is all wrong for some reason. Oh, this is probably Python 2 because the print statement doesn't have the parentheses. Yeah, and he's using this percentage stuff. I think it's I forgot. Oh, it was probably like this. I forgot how to use the format. Nice. I think now I'm getting somewhere. Now I can do all this stuff and see what I get. I know what to do it with the F. I think I'll just do it the way that I know, just to save time. So we have the function name here. Put it here. Online. Use one. There we go. So here should be like this. Should erase this return actually? Yeah. I'm gonna be right back. So this was the stuff that I was having trouble with understanding. I think, yeah, now it's clear to me that the hook for the trace has to be set before the function. That was what I wasn't sure. Like, what's the moment that this stuff starts tracing? on what exactly is tracing. So I think the way it works is when you set up this thing, then whatever comes after is gonna be traced through this thing here. So this creates sort of you create sort of like the script of how you're gonna, what information from the next frames you're gonna get. Maybe I should put a break on the first one just to see what I'm getting. I think I'm gonna run for 5 times. Let me see. 6. How about this? Well, let's see. If I equals 5, break. That should be 1 equal sign, you assign the value of I. So that should be true, true. For equality. X plus equals 1. Well, range already does that. Maybe I should do equals X. Yeah, makes more sense. But this is probably gonna run on the first loop. That's the problem. And this is another interesting thing. Yeah, so the way that it's working is that each time this line runs, it calls this, but it's not calling this on a loop. So that's the thing. It's not calling the function and then calling this on a loop. It's each time that this activates a line, I think it calls this thing to show the frame of the execution of that line. So I can't do that with the loop and the break. So the inspect is giving me this lines, and this line here is from this. Maybe I should erase this S here from this stuff. And I'm gonna go to the bathroom right back. Rivivux, what's up, man? I think I'm getting somewhere with the visualization stuff. I'll be right back. You're still there, man? Let's see. So the thing here is that this, at least I think, I'm not really sure, but I think this set trace works kind of like a hook, where I don't remember if you said, if you, that's what you said to me, but I didn't understand it really well. Now I think I'm kind of getting it. When you put this stuff here, it's gonna start tracking whatever code comes after it. So you have to put the whatever function you wanna track, you have to put it after you put this set trace here. And then each frame of this function, each line of execution is gonna be, whatever code you put here is gonna show that execution. If that makes sense. So each line this function runs, it goes through whatever you put here. And the frame is gonna be the frame, the event is gonna be whatever event is. And arg, I'm not really sure what it is, but I think it's kind of irrelevant. Event type, yeah. But I don't think it's very useful. At least, yeah. Probably frame and event are the only relevant things. Then this line here that I found from another guy on the internet, it says where the function, what function name is, the line number, and which frame is coming from. But the return event arg is the value that is being returned. Oh, okay. So I guess it can be useful depending on what you want to do. But now it's just a matter of trying to figure out how to connect all this stuff. Exception args contains the exception info. So it's pretty much the values of whatever the event is. So I guess that at least what I'm thinking right now is there's two ways to go about this, I think. One is to get the file names and then connect them, just like you did with your script on modules. The other is to get, probably I'll do both actually. So get the file names, connect the file names in a graph, and also get each function that is being run and create a graph for that. But it's probably gonna be extremely complex. So I'm not really sure if it's gonna be useful to visualize. It'll probably be necessary to change the configurations of the graph as well, so you can capture more information. Because this is like a 3,000 lines, 3 billion lines of code. It's also only tracking functions here on this script, and not tracking other events. Which I think at first is probably more reasonable, given the amount of lines here just with functions alone. Yeah, so I guess now the only thing I have to do is look up for the study how to build these
Now,
graphs.
network diagram is essentially a
Trace hook can return a new hook to be used inside the new scope, the local trace function. It's possible, for instance, to control tracing to only run line by line within certain modules or functions. This article is really good. It's probably the best one I found so far about this. Fuck. Here the global list of functions is kept the variable. You can change the current line number that Python is executing. What does that mean? You can change the current line number that Python is executing. So you can make a script jump from one line to a random line. I'm pretty happy about this actually. I was kind of losing hope, to be honest. But the article saved me. How do you do that? Would that be useful? Well, maybe. Yeah, maybe it would be useful to debug stuff, right? That could be used to do some really mean obfuscation. And what do you mean by obfuscation? Like hide stuff? I don't understand really well. I can see that it might be good for debugging stuff. Oh, trying to hide what the code is doing. Yeah, that's another area that I'm not really sure about is maybe you work with this. I don't know what you do, but how do people prevent other people from copying everything? Because every time I download a program, I can never just look at the files and see what is going on. At least I don't know how to do that. So I'm not really sure how that stuff works. How do you... If you say make it skip every online, that would be confusing to try and understand. But the question is, would it work though? Right? Would the program still work if you did that? think I'm gonna close this tracing stuff. Or maybe I'll leave it here just for later.
A way of showing relationships with each other.
It is really hard to hide the code of Python programs because it is interpreted. But with compiled stuff, C, C++, Sharp, Rust, and many more, you lose basically all context, like var names, function names, file numbers, and all that when you compile, meaning it is harder to read. Can decompile the binary. If you can decompile the binary, the code will just have random names for stuff. And if not, some links don't have good decompilers, you're stuck with the assembly. Yeah, but if it runs on your machine, it should be possible to figure out a way to understand it, right? Because the machine has to. Well, maybe the machine only runs the machine code. Yeah. But I mean, the logic of the execution is should be there, right? For the program to work. So there must be a way to use some tool to recompile stuff through the logic of execution. And I mean, who cares about the names really if you know the logic? But I never figured out how to do that. Yeah, obviously I'm not experienced, but I imagine people that are more experienced, like how do you hide stuff? I think it's kind of impossible, honestly. Like there must be a way to break everything. You can understand raw assembly, closest you should get your machine code. Real programs that way is really hard. Yeah, but hasn't someone created a tool to uh, compile from assembly to C++, let's say, or other languages? Like do the reverse process that our compiler does. And then you would have the source code of the things. Which is another really interesting discussion of how do you copyright this stuff? Obviously you can't reproduce the programs, but if you have the source code you can do pretty much the same thing and just change a few lines and then yeah, it's really interesting. It's interesting that doesn't happen that often as well. So I imagine there are a lot of reasons for that I'm just not aware about. The compilers, but they are not perfect. Now there are many ways to still protect the binary, and there are many ways to still protect the binary. Do you know about hacking stuff? For example, encrypting the assembly and decrypting it at runtime, meaning the compilers can't read the file directly. Oh, I understand what you mean. Hmm. And how do you get into that? That seems interesting as well. I know about Hack the Flag, I think is the name. Something like that, which is hacking competitions, but
You can create some really nice chains using this graph.
started tinkering with stuff using knowledge I already had. Hmm. What I'm most curious about is Well, actually, yeah, I don't know if you can classify this as hacking, but how the fuck does Microsoft has control over a computer? Like, is it because of the operational system or is it in the hardware? This kind of stuff I'm curious about. I feel like it's useful to know about hacking because the more things become attached to the internet is obviously more, it's gonna be a lot more important to know when someone is in your system. Pretty much everyone is watching you, what you do all the time, I'm assuming, nowadays, but it would be interesting to know, just see like the flow of information and what people have access to. I saw a couple of videos and interviews that people talk about the Facebook employee that they can watch all your conversations, whatever they want. It's really crazy. It's not made by Microsoft, and it would be easier for them to do it with the OS. Thing is, the OS is like in control of everything. Yeah, but does that mean if I buy a Microsoft PC like that comes installed with Windows 10 and I reboot it to Linux, they will lose the control? Like, don't you think they would think about putting something there so they can always see what you're doing, even if you change the thing? I mean, even in I don't know necessarily know, but I've seen a lot of videos that obviously the government and corporations are really interested in your data and they track a bunch of stuff on the deep web, on the Tor network and that stuff. So I imagine like they have a bunch of ways of tracking whatever you're doing. Yeah, but who cares about legal, right? When you have money, you're above the law because you're the one making the laws. At least in the current system we have.
And let me show you a few examples. So in this one here, we've got an example of Twitter.
Like, that's the problem. I can always find a loophole, right? Like, yeah, it's technically legal, but all of them do it all the time. Like, everyone's tracking everything. Software in the BIOS. Yeah, it's really hard to think about that for some reason for me. Like, the actual moment where the hardware becomes the software, it's kind of insane. Because the architecture is really complex, right? There's like billions of transmitters. With today's stuff, it's crazy. The first initial setup is the interesting part for me. How the fuck they do that? And how do you get better at understanding this stuff? I've researched some things. Maybe I'll study more in the future, but so far I only saw things on more the theoretical side. And I saw some videos about people building OS systems, but they usually use a pen drive or a built-in program that allows them to follow a bunch of instructions. They don't do it actually from the bottom, the ground up. Let me open this stuff. Steam? What is this? It's a course or a game? this looks really interesting. But it teach me how the OS works. Building a functional computer to challenging logic puzzles. How do I how the fuck do I how do I play this? Oh, maybe I have a Steam account, but I forgot the password. How much? There's been a long time since I don't use Steam. I don't even remember how it works. I guess there's somewhere here. Well, but that's the problem actually. If I buy it, can I do it on stream? Probably not, right? I wish there's some of these companies allowed uh, for me to do this on stream. You slowly build up to making a computer in your own assembly line. Because it's paid, right? So I'm not sure. Like, technically, I would be sharing their stuff for free with other people. When you have to pay it to use it. The only reason why I want to do this on stream is because I want to record as much as possible of my progress, so I have it like as a database of history to prove my experience, if that makes any sense. What do you mean? Is it possible to stream this? Do people do this? Really? Do they actually? It's actually allowed to stream paid content? I feel like there's a difference between, let's say, an entertainment game that you're not necessarily learning anything. Like, it's a paid game, but the value comes from playing it, if that makes sense. Because if you have a game where the value comes from the learning you get by playing, it's kind of different, I think. But I'm not really sure. But what type of games are they streaming, right? That's the thing. Like, obviously, I could do it and I think nobody would care, but I'm more concerned about the ethics of it, if that makes sense. Like, not because someone will punish me for it, because I don't think they would. Like, I don't have a lot of viewers, or nobody's gonna watch this, but 100% technical. It is technically maybe not under fair use to stream games like this, but no game maker would in their right mind deny streamers. Yeah, no, yeah, of course. I have to think about. I'll probably look at this later. I'll probably research as well if it's cool to stream this. I feel like there is a difference between. My main concern is that I don't want to rip off someone else. It's like the same concern I had from watching others people's stuff on stream. It's kind of like, I don't know, it doesn't feel, because you're using their content. So it's kind of like, but I've changed my mind with watching stuff, because I don't think if I watch a bunch of things together, not only just watch their content, I think it's fine. But for paid stuff and games and subscriptions for sites, I think it might be a little bit different. I'll be right back. I'm gonna get some energy drink. It's fair use, and one is actually fair use under law. Yeah, the law is actually questionable as well. That's the problem. I'm more about the ethics of it and the morals than the law, to be honest. Because in my case, it doesn't really matter, the law. I don't think any huge company would be interested in suing me or anything like that. But it's more a question of like interfering with someone else's work, you know. Even though, like, more a question of principles than a question of punishment for myself.
Sort of social media communities within Twitter, and you can see here that it looks really nice. You can also see quite clearly which one are the bigger ones, and they've got some good labeling going on, and this is essentially what a network graph is.
I'm not saying that's how it
I'll watch later.
should be. I'm saying that's how it is. So, how do we fix it?
Especially in developed world, I imagine this stuff is really, because it's extremely easy to copy code. I imagine if you just change one line, how the fuck you're gonna copyright a thing? And then how do you define? That's also a very, very interesting question of what's, obviously people say the execution is more important, but the ideas have value too. So what is the moment that the idea becomes the execution and it starts making sense to stop people from stealing from other people?
What's up, world? It's your boy Tom. Oh, come on.
This video is sponsored by CuriosityStream and by this, my new Nebula streaming series that you can watch for free when you join. More on that later.
Sell out. What's up, world? It's your boy Tom React. Let's see what this
Yeah, but you really think about that. Like, what is a copyright, you know? Every time you write a if statement, you're copying someone else because other people built that. Like, there's so much stuff that we take for granted that other people built for us. Like your chair, the cables, the camera, monitor screens, water bottles, plastic. You know what I mean? But it should you, like, you pay for the product, but it's kind of, I don't know. protecting the profit of a product by stopping others from making a cheaper copy. Yeah, the question is, can you stop it? That's the thing. I think like the value of things mostly comes from the momentum that it gets from people adopting it. Like the reason why you can copy other games is because the main game is already a thing, right? Because everybody is playing it. So because everybody believes that the game is the game, then nobody copies. But yeah, I'm not sure if that makes sense. Especially with the blockchain nowadays, but it's probably really hard as well to copy a game from normal centralized to the decentralized Solidity way of doing. Watch a movie if it was free on some random YouTube video. I don't recall the video was doing a reaction channel gang to make a point on yeah, the irony. The future is gonna be only reactions of reactions. It's gonna be videos of people reacting to their react, and it goes on forever.
Has to say. A few disclaimers before we start. While this video has been proofed and fact-checked by a team of legal experts, I am not a lawyer, and this is not a substitute for legal advice.
Yeah, I can tell that, mate.
I'm also talking a lot about YouTube and Google, companies that I benefit from enormously. Google even sponsored an entire
But the
series.
hacking part is really interesting for me. Especially understanding how companies are using data behind the scenes. Like how the fuck they are actually. It seems like Google has data of other companies, but how do they actually do that, and how do you visualize that? And I'm pretty sure there's some people in the planet that know how to do that, because they say everything is hackable, but it's I don't see a way to do that, or to even study that. It seems like there are some websites, but obviously they're not gonna make you great, I think. Trade data. But don't you think there are some hackers out there that can get information from anyone they want? If they really want it? Because they say, at least that's what people say, but I'm not really sure if that's true or not. That any phone is hackable. You can hack it, like it's really easy to hack phones for some reason. Soldier search history. Oh, that's crazy. Do you have to develop a unique way to hack things every time? That's why it's like they keep coming up with it's like a race where they constantly have to outdo the people trying to protect from hacking.
So you can follow one sort of from one place all the way along a chain to another place. And that's what we'll be creating in this series. Another example is with here, we've got Walmart. It's a bit blurry, so I apologize, but it's showing the sort of social influences of Walmart compared to other competitors.
Automated tools to exploit stuff like SQL injection, which is that you first need to find a point in the application that might be vulnerable to that type of attack. But that's probably basic stuff, right? I would imagine. Also, how do you learn how to hack without getting hacked yourself? It's kind of like buying guns, you know. You're gonna buy them, then the guy just steals your money because he has a gun and you don't.
And so again, this is a network graph.
Yeah, I've heard about CTFs. Maybe I should try this stuff. I capture the flag, right? Maybe I have a account for this. Other words, not breaking the law. Huh. But there are people that make money doing that, right? Is bug hunting, I think the name. I've researched that a while ago. Because the problem with this stuff is that is the difference between academia and real world stuff, right? Like, yeah, it's good to study physics equations and stuff, but in the real world, I imagine things will be very different. So it's one thing to try to hack something that you're really trying to hack it, and or you're just hacking for the challenge of it, if that makes sense. I imagine that it's probably different. But as I start, I think that this is probably good. And it is something that I want to do, for sure. Bug bounty is where you get paid when you find a bug exploit. And pen testing where you get paid to just try and get in. Let me see. I'm seeing if I have logging for this site. There are basically two types of pen testing. One where you try to hack a company, and one where you try to hack application product. And do they just put that out there in the internet? Like, oh, I have a account for this site. I'm afraid that I'm gonna lose focus though on the stuff that I'm doing. There's so much stuff to do that. Oh, and this, I think we have to pay for this stuff. I also would recommend this channel, they are great. Thank you. I think I've seen this guy before. His face looks familiar. It's all about the data these days. The issue is that they don't seem to make a lot of money, right? I think they make at most 70K a year, something like that. It's still cool to know though. Blue has a bug bounties program, but you should be careful and make sure you're trying to hack bug hunt or actually allows you to. For bug bounties depends on what you find. Hmm. Do you think I would get in trouble to try to hack a phone on stream? Like a random phone? I think it would be interesting to do stuff like this just to show to people like the power that these companies have and people don't understand. But maybe people do understand nowadays more than they did before. If it's your phone, no. If it is just some random phone in the street. No, this is just showing me how to do it. Copy the IP address of the machine that you just started on the task. Then in the attack box, right hand side, open up Firefox. In the attack box and paste the IP address into the URL bar. Drawing room, maybe. Use a VPN connector. Use the attack box. So I start the machine and learn what makes them vulnerable. Access deployed machines by the attack box or via OpenVPN. Put your knowledge into use by hacking real-world machines. Access machine via attack box or OpenVPN. So click the blue start attack box button at the top of this room. So this is probably the IP address that I have to copy somewhere. What tool are you working on? I was working on a visualization tool to see the execution scope of a script, to connect the different lines that a script activates, so I can study some libraries on Python But now I started seeing this hacking stuff. It's tough because I wanna finish the things that I'm doing, but this is also really interesting. I always wanted to learn how to hack things, and also to see if my information is available somewhere. Thanks for following Newtak. So the stuff from electrons that I put there is working now. Well, let me do something. Machine learning? What do you mean? On machine learning, you mean that? I'm trying to study sklearn, TensorFlow, Keras, those libraries for machine learning because eventually I want to build my own artificial learning library. And in order to do that, I want to deconstruct the libraries that exist and see how the best programmers did their library so I can understand better how everything works. But it's not a short-term goal, it's more of a long-term goal because it's obviously, at least for me, I don't have a lot of experience. It's really hard for me. So hopefully, and the reason why I'm doing that is because eventually I want to try to create my own architectures, and I don't want to rely on different libraries because you gain efficiency and speed when you use someone else's library, but you lose flexibility and creativity. So I think the best way is to just deconstruct everything into small blocks so I can try to build my own stuff depending on what I want to do. And along the way, you actually learn a bunch of stuff as well. If you're gonna hack, use VMware because it won't affect your Windows virtual machine. Well, yeah, maybe I should install that Kali Linux again. It's kind of a pain though to install a virtual machine, and yeah, but maybe that's necessary and I should just get over the initial comfort zone stuff. Because I remember every time that I was gonna use the virtual machine, I had to open up the virtual machine, then I don't know, it's kind of like a process. Prediction method and visualization learner in Python. Good. Yeah, sklearn is to build they provide you stuff to build the networks, but that's not what I want. Like, I want to deconstruct the library and see how they are doing that. Because when you use Keras and sklearn, you just type keras.dense the layer, something like that, and then the network is built for you, but it doesn't show how it actually is being built on the matrix operations and the vector operations behind the scenes. It's just showing the final product. Like, it's making it easier for you to implement them because you don't have to build it yourself. But then you lose the flexibility that you have if you only have the functions by themselves, if that makes sense. So if you have only the functions, for example, ideally, I want to have like a class maybe that has the backpropagation functions, the activation functions, and the layers, and I want to understand how the matrix operations are working so that I can modify the design and the backpropagation and maybe eventually build a visualization tool to see how different data is being fitted in relationship to these different architectures, if that makes sense. I'm also gonna do that, reading the source code. But the issue is that it's really complex. Like there's a bunch of files, and that's why the visualization tool was the stuff you built for me. The imported thing, the visualization for the importing is also really useful, because what it allows me to do is to see better like the hierarchy of importance of what do I need to read first, you know, how these things are connected. Because if you just look here, like there's a ton of functions here. And then obviously I can go line by line. And maybe I should be doing that and I'm just wasting time here, but I think it will be beneficial long term to it's a lot better in my mind to build a script that I have here. Like this is the stuff that I wanna understand how it works. Then from this script here, I create a visualization of what's going on this script and how everything is being connected. And then I research the library and see the source code, because I see the flow of the information, rather than just looking at the source code line by line. I did that as well, but it's not really good for me, at least. It's kind of like a mechanic. I don't know how to explain it. And I don't know, like it's also fun to build this stuff and learn along the way. Like there's a shit ton of things that I learned while trying to build this. Like all this frame stuff, all this import C's module, the Dunder methods. Like I wouldn't have learned this stuff if I went directly, I think. Exactly. And that's what I'm trying to do. Build these things. But it is also extremely painful and frustrating as well. Like if you you feel like an idiot all the time. It also makes me appreciate a lot more like everything that we have access to. Like if you think about it, the amount of work that went into building all these things is absolutely insane. Not just from Python, but from everything, like the computers, the like it's absolutely insane, and we just take it for granted because it's like part of the everyday life. Hopefully the robots overlords don't take over really fast, so I have the time to understand how this stuff works. It seems like this gonna happen, or probably already happened, a lot faster than anyone can predict. Where more and more intelligence is coming from artificial places, and people don't understand or recognize that this is already the case, pretty much. Where you have our algorithms dictating everything. But maybe the singularity is never gonna happen, and people on the other side are too concerned about it. And truth is somewhere in the middle, as always. I have to be careful as well to not show anything that can be potentially dangerous for me to show on stream. God, so what the fuck do I have to do here? Click the blue start attack box button at the top of this room. Where is this button? I don't see it anywhere. Attack box is what you use to access target machines. You start on tasks such as this one. So first start machine, connect access deployed machines by the attack box or via OpenVPN, which I think is this stuff. There's the same IP here. Put your knowledge, choose. Start the target machine shown on this task and wait 1 minute for it to configure. Damn, am I dumb? What am I missing here? Oh, here, maybe? No, here just connects. Copy the IP address of the machine that you just started on this task, then on the text box right hand side, open up Firefox. So I should copy this stuff here. Oh. Oh, this is the stuff that I opened up here. It's saying that I need to. I'm just gonna write it down. Okay. With the machine that you just started on this task, then on the text box right hand side. Then Firefox. And paste the IP address into the URL bar. So why is this not working? 10, 10, 158, 141. The machines you start on task left hand side are the target machines and are accessed by the attack box right hand side. Thirdly, you can access via OpenVPN. Yeah, so this is not working for some reason. Maybe I should click here or somewhere. When you're finished with a machine in any room, make sure you stop it by clicking the red terminate button. I think I'll do this stuff off stream, honestly. At least this initial phase where of configuring these things and figuring out how it works. And then maybe I'll do the hacking stuff on stream. I also have to see if that's the best way to figure out how to learn in the actual real world how stuff works. Introduction. Yeah, that's the one that I'm on, I think. Oh, now it's showing me a different page. This room will give you a brief overview on the different career paths in cybersecurity. You already have a basic idea on the different career tracks in the industry. Search the activities page for different walkthroughs and challenges. When some are structured learning, check out the learning paths. I already did this on a different time. Or whatever. I want to continue with the stuff that I was doing. Maybe this YouTube channel has stuff explaining that side. CTF video. Whatever.
The other day I saw on Twitter.
So I think I'm gonna learn how to do these graphs here. Do the network graphs with Python. And then I'm gonna try to link the file names and the functions of that script, the AI tester script, to build a graphical representation of how this stuff works. After I do that, then I'll think about it. The biggest issue with me is that I need focus, so Usually I have a bunch of things in my mind all the time, and I lose track of what I'm trying to do because there's so many things I'm trying to do at once. So I think I need to keep focus on this. In the next week, yeah, which is the beginning of the year, I'm gonna do a dopamine detox, and so I'm gonna have a bunch of time, and probably gonna stream a bunch of time. So during that week, I'm probably gonna do these challenges. I'm gonna try hack me, finish reading this book on C++, and just try to do a bunch of things.
Using the techniques that I will be showing you in this series.
And this video is fucked, so.
Hi all, welcome to the NetMinion Solutions, where your outcome always matters. Okay, so documentation you can to mark is the
Let me see if I have a file for this as well. I had this one. I think I'm gonna do it on this one and just erase all this stuff. Maybe I'll do another one. Yeah, I remember now that I was trying to build a function to build all the graphs automated. But then there was a problem with graph is that it didn't make the graphs the way that I wanted in a row. I had to stop the execution of the file, and this schedule thing wasn't working. So I think I might use this later eventually. So I think I'm gonna do it on this file. Rename this. Oh, maybe I have to do it. Maybe I'll do it on this file first. Yeah, the question is gonna be how do I get a trace and build the file without fucking up the trace. Maybe I'll have to do it inside the trace function. Yeah, put this on an object or a list or something like that outside of here, and then use that to build the graphs.
will be to execute this script. You can see that this script is being executed and it is saying that G is not defined because it is case sensitive language and I have used the small g over there, but howsoever here it was the bigger G. Now you can see that a graph and another picture is there, okay, and this picture you can see over here, this figure is generated by the Python again, okay, whereas the router check how many nodes I am having into my script. There is one more function which I can use over here, which will show me what is the vertices or what is the edges I will have total in the count. So we can just use
Maybe just
what
read
kind
the
of info we
documentation
have.
is actually
I
better.
can use the print function.
Another thing that I learned is if you press Windows and then the right key, this goes in the thing there. Then left key, this goes here, which is really useful. So apparently all I need to do is import network X Then create a graph object and then add nodes.
print annex dot showing the relation between such two nodes, out of which one
I think I'm
doesn't
gonna
exist.
spend 2 more
What does it
hours here.
mean? It means when adding the edges between two such nodes which are not into our node list currently, the edge function will add the nodes, or it will update the node list as well. So let me save it. Let me, okay, control. I cannot see like what is which node doesn't have the labels, you can say. Okay, so to add the labels, what I can give, I can just use a smaller kind of stuff over here. So with labels equal to true, so I will use like that. Now if I will press Ctrl B again, my graph will be appear again, and you can see that this time I have all of the stuff which is more, you know, like making more sense over here. So I told there is a relation between R1 and switch 1, and there is a relation between R1 and switch 1. Okay, but R2 and R3 are the nodes are there, but there is no relation in between them. So we can say this time we have more clear picture to us. Okay. Now let me show you more, okay, regarding this information. And maybe this time I will not add the nodes by my own. I'm just removing these kind of all the stuff. I will use some kind of another maybe function, and I will show you like how to, you know, create the nodes. So I am just giving maybe this time, I will remove this line also. Now into the G, what I can do, I can just use some kind of another function, path is 9. Now this is the one function. Likewise, we have many. So 0 is connected with 2 also, 3 also, 4 also, and likewise. Okay, every node is connected. Use such kind of stuff, and here maybe we can pass out some kind of value in. I need to use range command also because I need list. So why I'm calling why and from. So this is the function which will take all
I
the
think
nodes
actually
from
the first thing I'm gonna do is try to create a. I can close this file. I'm gonna try to create a list outside of there containing the names of the things that I want. So function name list file name. So I have func name, no, func name list, func file name list. So func name list, func name. The line and the thing is gonna be useful. So I have the name, the file name, then color, file name, list. And here I'm gonna append I think I'm gonna comment this out. Oops. File name list, color name list. So hopefully now I have to see if I print them outside here, what's gonna happen. Actually, press Ctrl D to create a copy. List in PyCharm. That's how it works. Yeah, so I have the name list, the file name, and the color name. And that's the problem. Well, at least it prints the list. Nice. I'm not sure if it's correct, but I can erase this stuff here. So what I want to do is use this list on the other script there. I'm gonna run, import this. I think if I don't put if name equals main on the bottom, when I import on the other file, it's gonna run the file automatically. So I'm gonna do that. So when I import this file, this one is gonna run this file, and then I'm gonna try to do things with this list here from the file. Try to build a graph with the lists. And I think I can make the connection by the index because the first ones are obviously gonna be, I think appends on the last index. So the first ones are gonna be the first files that were called. And the last one is gonna be the last files. Then I can make each node depending on the index. Probably. The only issue that I see is that I think I should put this on a try except block because it's gonna fail at the end when it gets to the bottom for some reason that I don't understand really well. But eventually I can also try to use the inspect.get source to get the source file of these functions as well. I'm not sure if that's gonna do anything. I think you can erase it. I'm gonna leave it here. Damn, this is running for a extremely long amount of time, so I'm not sure if I did something wrong now. Maybe it's just the printing that takes a lot of time, or something is off.
The list whatever you are providing. So I am passing out list 1 over here. Okay, so it will add all the nodes from this list.
I think I'm gonna read the documentation. It's probably gonna be better. I'm gonna watch these 2 videos here and then read the documentation.
Hi, this is a introduction to network analysis, social network analysis in Python. I'm going to focus, this is going to be really brief, I'm going to focus on NetworkX. It's worth noting that the other popular and really wonderful
I'll be right back.
library for doing network analysis is called iGraph. I would say, just a really quick summary from someone who I actually use iGraph more. I think it's a little more powerful for making visualizations and modifying visualizations. But I think NetworkX is also great and is maybe a little easier to get into. And so I'm going to show kind of really brief introduction to sort of two things: how to import data, and then how to create and visualize network statistics and the networks themselves. So I'm first going to load up. Oh yeah, let me clear the output. I'm going to load up the libraries we're going to use. We'll use NetworkX, Matplotlib, Pandas, and NumPy just a little bit. So the first thing is the idea of a graph object. And so NetworkX works with these graph objects. And so the first thing you want to do is create a graph object. One way of doing that is creating random graphs. There are a number of algorithms that they provide which create random graphs. This is one is the Barabashi-Albert graph. The basic idea of it, I really just using it as an example. But the basic idea of it is that nodes preferentially attach to other nodes based on how popular they already are. To give, I guess I should step back for a second and give sort of a higher level quick high-level explanation of what network analysis is. Network analysis is the idea of trying to study and understand relationships between entities. So instead of just studying entities, like people or users or animals or neurons, in order to understand a system, it's often really helpful, in fact, vital to understand as much as we can about the relationships between those entities as well. And so network analysis includes a number of both methodological and theoretical tools for understanding, for trying to gain understanding through examining those relationships. And so and NetworkX and some of these give like easy and quick ways to get access to some of the statistics and measures and visualizations that graph theorists have developed over the past few decades. So the main idea of NetworkX is we need to create a graph object. We're going to call it G throughout the tutorial. This is and the ones on the outside have few. So that's the capture the idea of power. I don't even know what approximate current. It also has a bunch of network level measures. So it's more about create name of the data frame, and then the source column, the name of the source column.
Okay, so let's begin with the second lecture for this series. So where we left it last time was that we showed you the uses of these kinds of analysis, what you can really do with this. This time we're actually going to dive in and we're going to actually start the analysis. So for this tutorial, so it uses Matplotlib on the backside of it. So really you should download that. So pip install Matplotlib. That's that. Okay. Again, requirement already satisfied because I already have it.
Yeah, now it prints
and for
everything.
C1, this is kind of optional for you guys, but
so I guess it was just the print that was taking long.
Better functionality for Matplotlib in the background here, and there's a couple more things that you can do with Seaborn. We're not really going to be looking into that, but if you do want it, just type in this command, pip install Seaborn, and that's going to download it for you. All right. So that's it for this part. I interrupted, by the way, just so you know. That's no error. I interrupted by myself.
Maybe
because, I didn't want it to run over all the way.
Maybe it would be better to create a list with a dictionary instead, where each object is gonna be the function name with the file name, because just the function name is probably not gonna be really useful without the file. But now I have to think about a way to create a dictionary with all of them. If I just do like this, it works. Func name. Func file name. Then here I'm gonna print this list.
So okay, when you have all of these, now we can really begin with the analysis here. So okay, let's see the basics. Let me create a new one, and let me rename it to text editors, but it'll make Matplotlib edges, and we have nodes. All right, so a really good feature on you specify the graph.
So add edge. Yeah, it's gonna be easier to read the documentation. Create random graph. Create edges. Add edges as disconnected lines in single trace and nodes as a scatter trace. So what is an edge exactly? Call a node points by the number of connections. This seems interesting. Another option would be to size points by the number of connections, i.e. node trace marker size node equals node adjacencies. Create network graph. Go figure data edge trace node trace. So I guess this is from the other ones. I guess I just took too much energy drink. Can't focus pretty well. Network graphs in Dash. Dash is the best way to build analytical apps in Python using plotly figures. Run the app below, run pip install dash cache, blah blah blah. Get started with the official Dash docs and I'll effortlessly install and deploy apps like this with Dash Enterprise. So this seems interesting because it's an object here. This is way more intuitive than this explanation here on the top. Create edges. Oh, this is the whole library. So what is an edge exactly?
Series on this channel last year.
Shill.
I'm friends with a few YouTube employees.
Of course you are.
So while all the words here are my own, YouTube don't even know I'm making this. You should know that if you're one of the outliers who's been screwed over by YouTube's copyright system, yeah, you will probably have a different view of parts of this. Although I hope you'll still agree with my conclusion. With all that said, enjoy the show.
Get on with it.
Not you.
Nice.
I realize saying YouTube's copyright system isn't broken.
So since this works, I have an object. I have a list with a bunch of objects with function name and file name, which is the description of where the object comes from, where the function comes from. I want to see if I can pull this from the other file. So I'm going to import the finder. Then I want to get this function here. For func in the finder dot func objects print func break.
Broken is a controversial claim to make when every week there seems to be a new headline about how a YouTube creator is being screwed over by false copyright claims or mistaken identity or deliberate copyright abuse. I'm not saying that the system is perfect. It's far from perfect, and I'll talk about that too. But I don't think it's fundamentally broken. In May 2019, a YouTube Minecraft player called Ollie had hundreds of his videos claimed by music label Warner Chappell using YouTube's Content ID system. His post about it made a lot of people righteously angry. He got permission to use a track from an independent composer as his intro music, and now a big corporation was claiming every video and taking all his revenue. Popular websites went so far as to claim that Ollie was the victim of outright theft, since 25% of his revenues were directed to Warner Chappell. But the follow-up wasn't seen by nearly as many people. Those claims were entirely legitimate. Yes, Ollie got permission to use that music from its composer, but that composer had sampled another piece of music that was owned by Warner Chappell without a license. So the permission that Ollie got was entirely useless. Warner Chappell was right, and Ollie was wrong. So here's how that should have worked in the world that current copyright law was designed for. First, everyone involved would have been part of a large company with a legal team. Lawyers from the music label would have contacted the lawyers for the video company, and they would have said, what's going on? You didn't license that. And the video company lawyers would have gone,
oh, I'm sorry, I had no idea. We bought that license in good faith from a third party. We should both talk to them.
at which point the third company's lawyers would get a very worrying phone call. And all the mess would almost certainly have been settled out of court, maybe by backroom dealings, maybe by teams of lawyers sending formal letters to each other. That was the world that copyright law was designed for, because individuals couldn't make things that were viewed by millions without corporate support. You needed a publisher or a broadcaster or a huge production company, and those companies had lawyers. The world has moved on, and copyright law hasn't. And the result is that when something like this happens in the world of relatively tiny independent online creators...
Yeah, that's a huge problem, not only on copyright, on everything. Technology is advancing far faster than regulation can, because all the bureaucracy and politics of everything. Oh, so this actually works. Nice. The only problem is this last. But this comes from this one. When it hits the end of the script, don't type as no attribute F Lilino. So it doesn't come from, yeah, just the exception that I'm printing here. Maybe if I just do pass, it won't show that. Let me see. But the great news is that it works, so it's probably gonna be, yeah, there we go. So now I have to think about, so I have the functions and I have the files that are coming from the functions. So now I have to think about ways to not only connect the, I have to connect the files and then with the description of each function. Yeah, so I have to create a graph where each node is index of this list, and that it represents the function and where it comes from. Then maybe think about a way to just get the description of the module. Just get the, well, but the full path is gonna be good as well. Yeah, but I'll think about that later. I think first I need to start by thinking about how to create the graph. I'll be right back. So the thing I just realized here is that GraphViz might be better for this than these network graphs, because I don't only want to show the connection, I want to show the direction of the connection as well. So maybe doing the graph the same way that the other script was making the graph. Then I'll probably need to figure out a way to fit more information in the graph as well. So because it's gonna be very complicated, very complex. All the connections from all the files. Yeah, it's a ton of lines. Really happy about this though. The only problem with using GraphViz is that it's on. I'll have to learn another language, which is Dot, I think. Which is probably not really hard to learn, but might be more of a pain in the ass to format the things the way I want them to be. Network or graph is a special representation of entities which have relationships among themselves. It is made up of a collection of two generic objects. Node, which represents an entity, and edge, which represents the connection between any two nodes. In a complex network, we also have attributes or features associated with each node and edge. For example, a person represented as a node may have attributes like age, gender, salary, etc. Similarly, an edge between two persons, which represents friend connection, may have attributes like friends. Since, another thing that I just thought about, maybe it's better to have the file name first and then the function. I think it makes more sense that way, because it's better to, but I think I would leave it like this. I'll do the graph first, then I'll think about it. Because of this complex nature, it becomes imperative that we represent a network intuitively such that it showcases as much information as possible. To do so, we first need to get acquainted with the different available tools. And that's the topic of this article, to go through the different options which help us visualize network. Let's get started. Before diving into visualizations, let us first understand how does a graph data look like and how can we load it into memory using networkx in Python. Below, you can see the tabular formulation of Game of Thrones social network. Here, node represents the characters of code, and edge between two characters means that their name co-occur in the vicinity of 15 words from one another in the books. Yeah, blah, blah, blah. Let's get to the point. Maybe I need to read this actually. The first two columns contain the nodes, and one pair of source and target represents the edge, an edge between the two characters. Only looking at the dataset of book 1, we have 187 unique characters and 684 connections. Also, the weight column gives a sense of the importance of the connection. Here's the number of times we have seen the name of two characters in the vicinity in book 1, should make this network manageable. Then consider the strong connections by keeping edges with weights bigger than 10. This streams down the graph to 80 nodes, characters, and 175 edges connections. Only this data, which is in a pandas data frame format, as a network, is quite easy. It can be done using. Yeah, maybe that's a better way actually. I didn't think about this. I can create a data frame instead and just print out just put out the different information on the data frame and download the data frame on the other file. It's probably going to be easier to make the connections that way. And then I can manipulate that data frame to find the values that exist in common with each other. I think that might be easier and more organized way to do it. Knowing this data, which is independent from as a network, is quite easy. Can be done using network X as follows. From pandas edge list, load pandas df network X graph. So we have source, target, edge attribute. Which source, these two columns. And edge attribute is the weight. That's the thing I'm not sure about though. So I'm gonna represent the weight. How many connections each one has. The variable g is now a network X graph on which we can perform graph-related operations. Now done with the prerequisite, let's explore different visualizations of terms one by one. This seems really interesting. So let me do the first part. I'm gonna put this on a pandas data frame. So let me erase this. Now I have to think about I think I'll just do df equals pd dot data frame. Well, the thing is I have to do this first, actually, so I can append this stuff there. Or maybe not, maybe, yeah, maybe I'll do it in the bottom. Because then I can put the list names instead. And I have columns equals so function name, function name, function name, function file name, file name, function name, function file name, What else? And the question is, do I put the line number or not? Is that gonna be useful? Because I have to think about which way is gonna be easier to build the graph. If I put more columns in between the columns I'm gonna use, it might be harder to build the graph. I think I'm gonna put it. Then if it's worse, I'm just gonna take it off. So function name, function file name. Func line number. Then I have to put it here. And I'll have to append this. Oh, I didn't put the color. Maybe it's not necessary. Color file name. So let's see. Function name, function file name, func name. Func file name. I'm gonna put it like this so it's easier to read. Line number. So name, file name, line number, and then color file name. Maybe we should put color line number as well. Yeah, I think I'm gonna put it this. And here, band, color line number. Yeah, now I think this is correct. Oh, this should come after the trace, I think. So I have the name of the function, the file name of the function, the line number, the color file name, and the color line number. 1, 2, 3, 4, 5. 3, 4, 5. And then I can just write CSV. Script graph.csv. Index equals false. I think that's the best way. Yeah, index equals false. So just gonna run this and see if it works. Or if it screams at me. 5 columns past data ahead. Huge amount of columns. So, each one of these should be a list. So it's definitely something I'm doing wrong here on the first argument. But if I do it without this, I don't think it's gonna work. Yeah. Maybe if I put it inside of this, it's probably not gonna work as well. Oh, it did work. Huh. It works, but it's probably not correct. Let me open the file. Yeah. It's not correct. So what am I doing wrong? So it's obviously on the size of the columns. It's weird because it should be all lists here. 5 lists. 1, 2, 3, 4, 5. I think I'm gonna research this here.
We have to work around what the law is meant to do.
I'll probably close this actually. It's probably better if I focus on the stuff that I trying to do right now and do this later. Even though I really want to do it. Oh, maybe I need to type data. Cause so that's another way. Yeah, maybe this way is gonna be better. Should do it as a dictionary. Let me try this first. It doesn't work. So I think I'm gonna try the other way. Hopefully now it works. So function name, func name list, function file name. Everything is correct. Arrays must all be same length. So I guess some of them are bigger than others. Can do here. Oh, actually, I can copy from here. It's easier. So they all have the same length. So it's probably something here. Maybe data equals this. It's crazy that it's 230,000 lines of code actually being executed there, which is absolutely insane. So what's going on here? The other way to do this would be to initialize the data frame in the beginning and then append the information as a row each time, but which I think is it would be slightly easier for me to do, but it's not the best way to solve it. So when I figure out how to do it this way. So when I do it like this, it becomes a row and not a column. This is the way that I'm doing, but for some reason it's not correct. If I separate this, but it shouldn't make any difference. Shouldn't have any difference. Or maybe this is redundant. Since I'm already doing this here. What's going on here? Maybe if I put index equals false, it's gonna work. Now it's showing me a different error. Hmm. It's really annoying.
Hey guys, today I'm going to show you a couple of quick ways to create some data frames. These are the ways I use it. I usually create data frames. There's many other ways, but these are the simplest for me. So let's begin.
I'll be right back.
import pandas as PD equals. Now we go.
At least once I have the data frame, it's gonna be a lot easier probably to build the graph.
Is the column name. So, and it goes the data frame, a second column.
Oh, maybe I know what's going on. Maybe it's trying to build the graph before it finishes building the thing. But I don't understand why it would be that way, but the thing is I'm doing everything right here, so I don't see how this is wrong. So maybe I'll try to build it here. Yeah, but the issue is if I build it here, then it's not very good because ideally I want something that I can replicate a bunch of times. And if I build it here, then I won't be able to read it later from here. Oh, because I think when I put something below here, it's gonna track that as well. I'm not sure. But it shouldn't matter because I'm just building the data frame from. Yeah, but then I'm also making the list bigger here because I'm running this trace thing. Now, I'm gonna try to do it here and see if that's the problem. If it is, then I'll have to create another script just to call this, just to transform that into a data frame. To separate that script from this script. Let's see if it works. It doesn't work. Arrays must all be the same way. So there's some weird thing going on here that I don't understand what it is. When it prints, they are all the same length, but For some reason, when it's building, it doesn't work. Maybe if I do it like this. Yeah. Huh.
You could have just done the following: data frame, bracket, revenue. We'll use the same numbers: 5, 6, 7. Let's close and comma. Then we could do another column. We'll call it cost, and we'll make this 5.0, 6.1, 7.2. Close the list, close the dictionary, and close the data frame. And now we got two columns, cost and revenue. Now notice that cost, even though I made it second, it was the first column here, and that's because by default Pandas just orders the columns in alphabetical order, so C is before R. And there you go. Two quick ways to create some data frames. Hope you enjoyed the video.
Dear friends, in this tutorial we are going to look into different ways of creating Pandas data frame. Now if you have watched my previous two tutorials, then you should have a basic understanding on Pandas framework, and also you should be familiar with data frame in general. So let's start Jupyter Notebook as usual. Now you can use PyCharm, Notepad++, whatever IDE you prefer, but I like Jupyter Notebook because it is great with data visualization. Here I'm going to click on new button to start a new notebook. Okay, now I already have a CSV file for weather data, so you can see that this is a weather data where you have days, temperature, and so on. Now the first way of creating a data frame is to directly read this CSV. Okay, so I'm going to import pandas as PD, and then what you can do is pd dot read CSV. Read CSV is a method that will read CSV into a as my Jupyter. My second way is to create a data frame from an Excel file. Okay, so the same way that you can use read CSV, you can use read Excel to create a data frame using a Python dictionary. Okay, so here in this bracket you can specify a Python dictionary, and that dictionary needs to have the data needed for your data frame. Okay, so I have this little file where I have saved that dictionary, so I'm just going to copy paste to save time on recording. Okay, so as you can see that in my dictionary I have these different keys, and each of these keys represent the column in my data frame. So you can see day, temperature, wind speed, and event, and these are my row values. Okay, so now I need to pass this dictionary as an argument into this function, and when you run this, again my data frame is created successfully. So this was the third way. The fourth way of creating a data frame is to use a tuples list. So I'm just going to copy tuples list here. You can see that this is a list, and the list contains tuple. Each element in the list is a tuple. Okay, and this tuple is nothing but a row in your data frame. Okay, now when you create your data frame, one thing you need to do is you need to provide column names. Okay, so here my column is day, then the second guy is temperature, then you have wind speed, and then you have event. When you run this, once again it created a data frame successfully. So this,
Maybe if I try to debug this, stopping here and step over this stuff. 1, 2, 3. Oh, I think I understand now. What's wrong? I think the problem is that the columns are messed up. We should put each of them in parentheses, in square brackets. This is not gonna show me. Maybe that's the problem. Oops. So hopefully this works. Huh. So this is creating a bunch of columns, not the rows. That's the problem. And to pass each one of them as values for the rows, not the columns. But apparently this way it understands that I'm passing value for columns in the first array here. And I tried doing like this and doesn't work as well. Just creates a 5 columns pass. Plus data head in 1 column. Maybe if I do it like this. Oops. I have a feeling this is not gonna work, but it's worth trying.
This was the fourth way of creating a data frame using a list of tuples. And don't forget to mention the name of columns here. Okay. All right. The last way that we are going to cover is a list of dictionaries. So just let me just copy it from here. Okay. Now here, the difference between the first approach this approach where I had a dictionary and each key contained values, row values, the difference here is that each element in the list represents one row along with its column specification. So you can see this is a list and each record here has column value. So let's now, and you can see that it created this dictionary ways of data frame. So if you sources such as CSV Excel, which we covered, but
Hello everyone, welcome to Geeks for Geeks. In this video, we are going to know how can we create a data frame using list. And there are various methods to achieve this. And we are going to see them one by one. So let's see the first topic, that is using a simple list. So it is using a simple list. In this, we are going to take only one list and we are going to form a data frame using that list. So let's create that list. So I'm going to call my list as LST and it is going to contain a few numbers. So let's take it 10, then
What do you mean by that? contained in the first argument. Isn't it contained already in this list? From what I understand here, that when I pass it like this, it understands that each one of these is a column. I don't think. Let me run like this. But it doesn't work like this. It says it's not the same length. 5 columns passed. Past data has this amount of columns. So it's understanding that each one of these is a column, like I think. So this creates a list of columns instead of rows. And it thinks each one is a row. I think it understands each one is a column. Because each one of these has a list of a bunch of values. Are you talking about the first one or the columns one? Because it's saying 230,000 columns. 5 columns passed. Past data had 230,000 columns. So assume that it's thinking that each one of these represents a list of columns, not rows. And I don't understand why. Dict with the keys as the column names. I tried that, it didn't work as well. It's weird. I'm not sure what's going on. I'm not sure if it's a problem with this or if it's a problem with the set trace stuff. Might be a problem with the set trace. For some weird reason. I'm gonna do it again just so you see what I'm talking about. Let me build it and you see. No, I comment this off. This is correct, right? Arrays must all be the same length. And then I printed the length of the arrays and they are all the same. So I'm not really sure what's going on. Do you want me to print the length? It must be different, right? But I'm not sure how it's possible. Oh, let me do the other way, actually. It's giving the same values here. But the thing, you see, the error comes before it prints, even though the function is later. So I'm not sure. I think it's something to do with the set trace function. That's the problem. Are you sure? But why would say that the arrays have to be the same length if they are the same? Doesn't make any sense. You call the function the trace will start to modify them again, right? Yeah, that's what I'm thinking about. Right, that's the problem. But when I tried to do it from this file, it also gave me the same error. So I think I'm gonna have to do it row by row, probably. Try doing none sys before creating the data frame. Here, sts set trace none. What is sts? Is it a library or sys? Sys. Here, like this. Maybe I'll delete this as well. Yeah, I understand now. Damn, you're a genius, man. Thanks. Now it works. Yeah, so it was just that, I guess. But I didn't even think about doing none here. I was thinking about putting row by row before. But I think now it's correct. Hopefully. Nice. There we go. Now the only issue is that there are 230,000 files, lines, and the graph is gonna have to connect all of them, which I'm not sure if this is gonna be really useful. But at least this data frame is probably really useful to study as well. Nice. There we go. Hmm. This is awesome, actually. Really? The connection line to line is a terrible idea. Block to block would be better. Where blocks is called until a branch, like a function call, if case, loop, etc. I mean, there's no reason why I need to limit myself, right? It's better to try to do all of them and then see which ones feel better as you study. No idea what the name was. Yeah, these things usually they come when you are not expecting them anymore. But I think this is the right direction. It's exactly what I wanted in the beginning. Now it's just to figure out how to get this data frame. Now I don't need this. No, I don't need to import the file anymore. I can just do. I have to import pandas. There we go. Oops. The latest version is 1.1, which was released, wow, 2013. It's almost a decade ago. That's crazy. What's the name? Do you feel like it's gonna be better to use GraphViz for the graph or to try to do network? You can use this one here. From pandas edge list df source equals column target column. And I'm gonna put edge attribute. I think I'll do both. I'll do the network first, then GraphViz. Click on the image below to see larger version. So this is a library for creating graphs. Below is the generator image from the code above. If you're having issues with the image below, try the direct link to image. So main person. Oh, so this is using GraphViz. can each do this usage guide first. Outputs. Python call graph was made to be a visual profiling tool for Python applications. It uses a debugging Python function called sys.setTrace, which makes a callback every time your code enters or leaves function. So is exactly what I was building. 8 years old, so. Oh, if it works, who cares, right? It's really weird to me that this stuff doesn't get talked about more. Maybe there's a reason. Maybe people are not interested. I don't know. Oh. Well, it's using sys set trace, which is the same thing that I've used. Python call graph should track the name of every function called, as well as which function called which, the time taken within each function ever calls, etc. It's able to generate different types of outputs and visualizations. Initially, Python call graph was only used to generate dot files for GraphViz, and as of version 1.00, it can also generate JSON files. Creating custom outputs is fairly easy by subclassing the output class. You can either use the command line interface for a quick visualization of a Python script, or the PyCalca for more fine-grained settings. GraphViz, or which should be installed before attempting to use it. Filtering is sometimes needed when the output of Python call graph is overwhelming. Or if you want to only measure a small portion of your program, the filtering guide below is based on the FilterPy. So we have a class called banana. The code to measure it without any configuration apart from the output file. So from this import graph. So it creates a GraphViz object, filter none.png. If PyCall graph outputs, So he puts whatever is gonna output here. Maximum depth. Let's say you're only interested in the first level of calls. You can specify this using config max depth. But this is only for a class. Let me see. Let me see this one that I was doing here, because this is already made for columns, for data frames. I just wanna see how I can show this G thing. Just wanna see this graph to see what it will output. It's probably, I think what's gonna happen, what's more likely to happen, is gonna be too much information for one graph. like the TensorFlow graph, where it's just too much stuff, so it doesn't fit in one graph. Let me run this and see what happens. And the problem is I have to figure out how to show this. Maybe this works. Yeah, no attribute. Network has its own drawing module which provides multiple options for plotting. You can find the visualization for some of the draw modules in the package. Using any of them is fairly easy, as you need to do is call the module and pass the G graph variable, and the package does the rest. Oh, so here's the description. Maybe now it will work. So it doesn't work. So df maybe I'm missing something. Maybe I need the edge attributes stuff. I try to put anything here just to see if it works. Well, let me leave it blank and try. Invalid. So I'm gonna do color name. Random state index is incorrect. I don't understand what that is. Maybe I should research that. This makes the default option not the obvious choice if you're using larger network data. While the visualizing option is built in the default Python graph package and is quite easy to call, it's highly counterintuitive and good only for small networks. Most of the time with large networks, any of the inbuilt module calls doesn't make a lot of sense. This makes the default option not the obvious choice if you're using larger network data. Another downside is not interactive, so the plot is a fixed graph. This is a major drawback as there are other options which let you manually interact and play with the graph. With this skill, let's move on to our next option. So I have an idea here. I'm gonna make this head 5. That way I decrease the size of the df and see if it works. Yeah, for some reason it's giving me this bullshit here. Random state is incorrect. I'll be right back. We'll go to the bathroom. Ideally, I want to have something that is interactive as well, where every time I press tab or space or something like that, I go from line to line. That would be perfect, I think, to study. That way I can investigate line by line what's going on. It's an interactive network visualization Python package which takes the network X graph as input. It also provides multiple styling options to customize the nodes, edges, and even a complete layout. The best part, it can be done on the go using a setting pane where you can play with the various options and export the final settings in form of a Python dictionary. This dictionary can later be passed as config while calling the function, resulting as it was drawing of the network. Apart from this, there's a visualization of the basic option of zooming, selecting hover, among others. By default, drawing our GOAT network can be done easily by so I think I'm gonna try this one and probably research why it's not working after. So I need to download this. Assume it's PyVis. At least I'm getting close. Yeah, there we go. Net equals network. Notebook goes through. That's from Max. Oh, at least this one doesn't give me an error, but it also doesn't show anything, so. From X, load the network graph. Oh, so I need to have the graph first, I guess. But it should be made here. Try without an argument. The goal of this project is to build a Python-based approach to constructing and visualize network graphs in the same space. PyVis network can be customized on a per node or per edge basis. Nodes can be given colors, sizes, labels, and other metadata. Each graph can be interacted with, allowing the dragging, hovering, and selection of nodes and edges. Each graph's layout algorithm can be tweaked as well to allow experimentation with rendering large graphs. The PyVis library is meant for quick generation of visual networks graphs, minimal Python code. It is designed as a wrapper around the popular JavaScript Viz.js library found at this link. Oh, so that's the one that we were trying to use before. That's a wrapper, Python wrapper for this one, which is great. Getting started, all networks must be instantiated as a network class instance. Add nodes to the network. Net.addNode1, label node1. Node ID equals 1 and label node1. Node 2. Here, the first parameter to the addNode method is the desired ID to give the node. This can be a string or a numeric. The label argument is the string that will be visibly attached to the node in the final visualization. No label argument is specified in the node. ID will be used as a label. You can also add a list of nodes. Net.addNodes. Maybe if I try it this way. So I'm gonna do it from the start here, following the documentation. So first you do an object. Then net.addNode. Then I can use df and the column as a list, hopefully. But I'm not sure if the column is a list or a series. Maybe I should put the column names here, just so I don't have to look it up all the time. Actually, I'm gonna do it like this. And that's much better. Now, Windows right arrow key. There we go. And node nodes, node ID labels, node properties. So I think I stopped here. Yeah, you can also add a list of nodes. Network dot add nodes. Accepts any iterable as long as the contents are strings or numerics. Or add nodes, not add nodes. A call to add nodes supports various node properties that can be set individually. All of these properties can be found here, courtesy of Viz.js. For the direct byte translation of these attributes reference the network.addNode docs. Okay. Through no fault of PyViz, some of the attributes in the Viz.js documentation do not work as expected, or at all. PyViz can translate each into the JavaScript elements for Viz.js, but after that, it's up to Viz.js. Indexing a node. Use the getNode method to index a node by its ID. Adding lists of nodes with properties. When using the network add nodes method, optional keyword arguments can be passed in to add properties to these nodes as well. The valid properties in this case are size, value, title, XY label, color. Each of these keywords args must be the same length as the node parameter to the method. If you mouse over each node, see the title. Edges. Assuming the network's nodes exist, the edges can then be added according to node IDs. Yeah, but what if I don't have the IDs? Edges can contain a weight attribute as well. Edges can be customized in Edges can be customized and documentation on options can be found at Edge method documentation or by referencing the original SGS module. Arrows. Also, you can set arrows. To draw an arrow with default settings, a string can be supplied. For example, arrow to from middle or to from. Any combination with any separating symbol is fine. If you want to control the size of the arrowheads, you can supply an object. It's kind of confusing. I stopped here. An easy way to visualize and construct PyViz network is to use NetworkX and use PyViz built-in NetworkX helper method to translate the graph. Note that the NetworkX node properties with the same names as those consumed by PyViz are translated directly to the corresponding named PyViz node attributes. Visualization, the displaying of a graph is achieved by a single method call after the underlying network is constructed. The interactive visualization is presented as a static HTML file. Oh, it created the graph here. I didn't see that. But how do I visualize this? Maybe if I open this on the browser somehow. Huh. So that's definitely not the accuracy I was expecting. But it's better than nothing at least. So I think he built the graph for the script and not the data frame. Let me delete this. The interactive visualization is presented in net enable physics true and show my graph. Triggering the toggle physics method allows for more fluid graph interactions. So why is giving me this? Maybe I need to set this up after I have the graph. The following code blocks are the minimal example of capabilities of PyViz. Network height, font color. Oh, here is using a data frame. Sources, got data source, target weight. Edge data, zip source, sources target weight. So I think I'm gonna do it like it's doing there. So first it creates the graph, object, set the physics layout of the network. So this should come before. I think I'm gonna erase here. Sources equals df. Function name targets equals this. The only thing is the weight that I will have to think about it. Because I have to think about how often, how I'm gonna do the frequency that lines show up. I'll probably have to play around with the data frame, and see the values, unique values, the value counts, and stuff like that. Yeah, so I think I'm gonna try it without using the weights first. I think the zip function creates a dictionary of sources and targets, probably. For eating edge data. Source. Oh, so it's looping through the dictionary and creating the edges that way. Mine is just net, so net dot add node source bottom source. Here's node and here's add edge. This. Oh, so the edge is using the weight. Huh. So maybe, oh, I can do it without the value. I can probably erase these ones. Neighbor map equal map dot get adjacent list. I can just copy this stuff. Add neighbor data to node hover data. Here's not show. Script graph. Let's see if this works. If you want to try out the above code, the CSV data source can be downloaded. The title attribute of each node is responsible for rendering data on hold hover. Using the configuration UI to dynamically tweak network settings. You also have the option of supplying your visualization with your UI used to dynamically alter some of the settings. Oh, nice. It also hopefully it worked. I imagine it's gonna be ridiculously big. And I'm not sure. That's my main concern, that I think I'm gonna have to study a bunch of stuff. I'm gonna have to spend a bunch of time studying these visualization tools in order to find a way to fit large amounts of data into these graphs. Damn. Is this the actual thing? Damn, that's crazy. You can see that creates a pattern here. That's actually super interesting. If it is actually this stuff. That's great. You can see there's a fractal pattern here. It almost looks like a tree. Literally. It actually worked. That's really cool. So I think I'm done for today. I'm probably gonna spend a shit ton of time, like a lot of time, playing around with this visualization. This is super interesting to me, actually, because I think there's a lot more connections between this, not only to study, but the actual geometry of the things and how did they work in practice. Yeah, that's insane, right? I wish this thing was bigger, actually. It's so cool. I'll have to think about, but there's definitely something here. But I think I'm done for today. Next week, I'm probably gonna stream a bunch of time because I'm not gonna be doing anything else like dopamine detox. So I'm probably gonna spend a bunch of time studying this stuff, and I'm probably not gonna stream tomorrow. Yeah. So probably I'll come back on the first Saturday, the first day of the year. So see you then.